Quantum Weirdness, Chapter 2. Einstein doesn't play dice. I think that a particle must have a separate reality independent of the measurements. That is, an electron has spin, location, and so forth, even when it is not being measured. I like to think that the moon is there even if I am not looking at it. Thus, the last and most successful creation of theoretical physics, namely quantum mechanics, QM, differs fundamentally from both Newton's mechanics and Maxwell's EM field. For the quantities which figure in QM's laws make no claim to describe physical reality itself, but only probabilities of the occurrence of a physical reality that we have in view. I cannot but confess that I attach only a transitory importance to this interpretation. I still believe in the possibility of a model of reality, that is to say, of a theory which represents things themselves and not merely the probability of their occurrence. On the other hand, it seems to me certain that we must give up the idea of complete localization of the particle in a theoretical model. This seems to me the permanent upshot of Heisenberg's principle of uncertainty. What is it about quantum theory that so troubled Einstein that he would spend nearly a quarter of his life trying to find a replacement for it? The answer is perhaps a bit simpler than we might suspect. Einstein was a realist and believed in an objective universe that exists outside of our subjective observations of it. What so bothered Einstein about quantum theory, even though he contributed to it with his photoelectric effect and Brownian motion papers and appreciated its many strengths, was that it was inherently probabilistic, and that at its philosophic and methodological core was an uncertainty principle that pointed to the variability of human measurement. As John Wheeler, the eminent physicist at Cornell and Princeton and the University of Texas at Austin, later stated, "There is no phenomena unless it is an observed phenomena." This was intolerable to Einstein, since, as he suggested to his eventual biographer and physics colleague, Abraham Pais, "The moon really does exist even when I don't look at it." Einstein's objections to quantum theory took two major turns. First, almost from the outset, Einstein attempted to show how the new quantum mechanics as defined by Heisenberg and Bohr was mistaken. Later, Einstein accepted to some measure the correctness of quantum theory, but tried to point out how it was an incomplete theory, and most likely a bridge theory to something much more comprehensive and complete. One of the key sticking points for Einstein was the breakdown of individual causality inherent in quantum theory, where a measuring device a priori determines the outcome of a quantum state. As Joshua Roebke in The Reality Tests points out, Schrödinger and Heisenberg independently uncovered dual descriptions of particles and atoms. Later, the theories proved equivalent. Then, in 1926, Heisenberg's previous advisor, Max Born, discovered why no one had found a physical interpretation for Schrödinger's wave function. They are not physical waves at all. Rather, the wave function includes all the possible states of a system. Before a measurement, those states exist in superposition, wherein every possible outcome is described at the same time. Superposition is one of the defining qualities of quantum mechanics and implies that individual events cannot be predicted. Only the probability of an experimental outcome can be derived. Seed, Volume 16. The fact that quantum theory involves a connection between a measuring device and how we can ascertain reality was, for Einstein, fundamentally problematic. In a famous letter to Max Born, dated March 3, 1947, Einstein outlines why. "I cannot make a case for my attitude in physics which you would consider at all reasonable. I admit, of course, that there is a considerable amount of validity in the statistical approach which you were the first to recognize clearly as necessary given the framework of the existing formalism. I cannot seriously believe in it because the theory cannot be reconciled with the idea that physics should represent a reality in time and space, free from spooky actions at a distance. I am, however, not yet firmly convinced that it can really be achieved with a continuous field theory, although I have discovered a possible way of doing this which so far seems quite reasonable. The calculation difficulties are so great that I will be biting the dust long before I myself can be fully convinced of it. But I am quite convinced that someone will eventually come up with a theory whose objects, connected by laws, are not probabilities but considered facts, as used to be taken for granted until quite recently. I cannot, however, base this conviction on logical reasons, but can only produce my little finger as witness. That is, I offer no authority which would be able to command any kind of respect outside of my own hand. Perhaps the key line in the above referenced letter by Einstein is this: I cannot seriously believe in it because the theory cannot be reconciled with the idea that physics should represent a reality in space and time, free from spooky actions at a distance. What reality was Einstein presupposing here? An external world freed from man's measurement, a world which exists truly and clearly apart from human subjectivity. But as Einstein rightly surmised, this objective world collapses with Heisenberg's uncertainty principle, since external reality at its most fundamental constituency, atoms, is absolutely unknowable, except through a measuring device which in and of itself alters what is known. In other words, quantum mechanics is a statement about reality itself, and what it is saying is that there is no world out there, apart from our observations of it. Our observations, in other words, are part and parcel of what we observe. The dualistic idea of a world apart from ourselves is a fiction. For Einstein, this was the very antithesis of science in general and physics in particular. The whole scientific enterprise was predicated on the notion of an external world which was independent of the machinations of the subjective participants that arose within it. But the real culprit here in Einstein's mind is the introduction of probability and statistics as a final pathway for understanding the underlying laws of subatomic materials. While Einstein readily concedes the powerful utility of Born's statistical understanding of wave matrices, his little finger tells him that quantum mechanics is merely a prelude to a greater and more unified theory which will eventually transcend probability functions and yield a straightforward and causal and objective explanation of how and why matter behaves the way it does. As Einstein near the end of his life pointed out, it seems to be clear, therefore, that Born's statistical interpretation of quantum theory is the only possible one. The wave function does not in any way describe a state which could be that of a single system. It relates rather to many systems, to an ensemble of systems, in the sense of statistical mechanics. Further, he elaborates on why he finds the statistical method a transitory one. Thus, the last and most successful creation of theoretical physics, namely quantum mechanics, QM, differs fundamentally from both Newton's mechanics and Maxwell's EM field. For the quantities which figure in QM's laws make no claim to describe physical reality itself, but only probabilities of the occurrence of a physical reality that we have in view. I cannot but confess that I attach only a transitory importance to this interpretation. I still believe in the possibility of a model of reality, that is to say, of a theory which represents things themselves, and not merely the probability of their occurrence. On the other hand, it seems to me certain that we must give up the idea of complete localization of the particle in a theoretical model. This seems to me the permanent upshot of Heisenberg's principle of uncertainty. Why was Einstein so recalcitrant to a theory that measured only probabilities, especially if those very probabilities led to amazingly exact results? Some scholars have suggested that Einstein's stubbornness was due to his personal psychology that looked for an order that he didn't see in the world of human affairs. Or perhaps it stemmed from Einstein's first epiphany as a young boy at the age of 11, where he was able to prove for himself Pythagoras' theorem. Along this line of reasoning, it has been argued that Einstein's passion in science was fueled by his even greater passion for discovering a truth apart from human artifice. In any case, whatever personal motivations lie behind Einstein's resistance to a purely statistical interpretation of physics, it is unassailable that he also found it philosophical objectionable. One of Einstein's more pregnant, even if a cryptic, remarks about human ideas and reality is captured in his January 27, 1921 lecture to the Prussian Academy of Sciences in Berlin, Germany. At this point, an enigma presents itself that in all ages has agitated inquiring minds. How can it be that mathematics, being after all a product of human thought which is independent of experience, is so admirably appropriate to the objects of reality? Is human reason, then, without experience, merely by taking thought, able to fathom the properties of real things? In my opinion, the answer to this question is, briefly, this. As far as the laws of mathematics refer to reality, they are not certain, and as far as they are certain, they do not refer to reality. There are many ways to interpret what Einstein actually means here, especially in light of its philosophic import. But I think it presents a clearer beacon into why Einstein would have resisted a purely mathematical interpretation of physics, as was presented several years later by Born, Heisenberg, Bohr, et al. In their formulation of quantum mechanics. Einstein, ever being the realist, understood that human concepts were in themselves limited in their import, and thus to conflate a theory in its present state for the ultimate state of reality was not only mistaken, but wholly naive. Ironically, in this sense, Einstein was a metaphysician whose little finger or intuition pointed beyond mere empiricism. But Einstein's metaphysic wasn't of a religious or a spiritual kind, but rather for a reality that literally transcends human cognition and which forever escapes human thought to entrap it. As Einstein explained in his lengthy analysis of Bertrand Russell's theory of knowledge, in the evolution of philosophical thought through the centuries, the following question has played a major role. What knowledge is pure thought able to supply independently of sense perception? Is there any such knowledge? If not, what precisely is the relation between our knowledge and the raw material furnished by sense impressions? There has been an increasing skepticism concerning every attempt by means of pure thought to learn something about the objective world, about the world of things, in contrast to the world of concepts and ideas. During philosophy's childhood, it was rather generally believed that it is possible to find everything which can be known by means of mere reflection. It was an illusion which anyone can easily understand if, for a moment, he dismisses what he has learned from later philosophy and from natural science. He will not be surprised to find that Plato ascribed a higher reality to ideas than to empirically experienceable things. Even in Spinoza, and as late as in Hegel, this prejudice was the vitalizing force which seems still to have played the major role. The more aristocratic illusion concerning the unlimited penetrative power of thought has as its counterpart the more plebeian illusion of naive realism, according to which things are, as they are perceived by us through our senses. This illusion dominates the daily life of men and of animals. It is also the point of departure in all of the sciences, especially of the natural sciences. As Russell wrote, "We all start from naive realism, that is, the doctrine that things are what they seem. We think that grass is green, that stones are hard, and that snow is cold. But physics assures us that the greenness of grass, the hardness of stones, and the coldness of snow are not the greenness, hardness, and coldness that we know in our own experience, but something very different. The observer, when he seems to himself to be observing a stone, is really, if physics is to be believed, observing the effects of the stone upon himself." Gradually, the conviction gained recognition that all knowledge about things is exclusively a working over of the raw material furnished by the senses. Galileo and Hume first upheld this principle with full clarity and decisiveness. Hume saw that concepts which we must regard as essential, such as, for example, causal connection, cannot be gained from material given to us by the senses. This insight led him to a skeptical attitude as concerns knowledge of any kind. Man has an intense desire for assured knowledge. That is why Hume's clear message seemed crushing. The sensory raw material, the only source of our knowledge, through habit, may lead us to belief and expectation, but not to the knowledge and still less to the understanding of lawful relations. Then Kant took the stage with an idea which, though certainly untenable in the form in which he put it, signified a step towards the solution of Hume's dilemma. Whatever in knowledge is of empirical origin is never certain. If, therefore, we have definitely assured knowledge, it must be grounded in reason itself. This is held to be the case, for example, in the propositions of geometry and the principles of causality. These and certain other types of knowledge are, so to speak, a part of the implements of thinking and therefore do not previously have to be gained from sense data. That is, they are a priori knowledge. Today, everyone knows, of course, that the mentioned concepts contain nothing of the certainty, of the inherent necessity, which Kant had attributed to them. The following, however, appears to me to be correct in Kant's statement of the problem. In thinking we use with a certain right, concepts to which there is no access from the materials of sensory experience, if the situation is viewed from the logical point of view. As a matter of fact, I am convinced that even much more is to be asserted. The concepts which arise in our thought and in our linguistic expressions are all, when viewed logically, the free creations of thought which cannot inductively be gained from sense experiences. This is not so easily noticed only because we have the habit of combining certain concepts and conceptual relations, propositions, so definitely with certain sense experiences that we do not become conscious of the gulf, logically unbridgeable, which separates the world of sensory experiences from the world of concepts and propositions. Thus, for example, the series of integers is obviously an invention of the human mind, a self-created tool which simplifies the ordering of certain sensory experiences. But there is no way in which this concept could be made to grow, as it were, directly out of sense experiences. As soon as one is at home in Hume's critique, one is easily led to believe that all those concepts and propositions which cannot be deduced from the sensory raw material are, on account of their metaphysical character, to be removed from thinking. For all thought acquires material content only through its relationship with that sensory material. This latter proposition I take to be entirely true, but I hold the prescription for thinking which is grounded on this proposition to be false. For this claim, if only carried through consistently, absolutely excludes thinking of any kind as metaphysical. In order that thinking might not degenerate into metaphysics or into empty talk, it is only necessary that enough propositions of the conceptual system be firmly enough connected with sensory experiences, and that the conceptual system, in view of its task of ordering and surveying sense experience, should show as much unity and parsimony as possible. Beyond that, however, the system is, as regards logic, a free play with symbols according to, logically, arbitrarily given rules of the game. All this applies as much, and in the same manner, to the thinking in daily life as to the more consciously and systematically constructed thinking in the sciences. By his clear critique, Hume did not only advance philosophy in a decisive way, but also, though through no fault of his, created a danger for philosophy in that, following his critique, a fateful fear of metaphysics arose which has come to be a malady of contemporary empiricist philosophizing. This malady is the counterpart to that earlier philosophizing in the clouds, which thought it could neglect and dispense with what was given by the senses. It finally turns out that one can, after all, not get along without metaphysics. In summary, the reason Einstein so resisted the philosophical implications of quantum theory, the observer alters the observed, was because it puts the cart before the horse, or more accurately in this context, it puts man's present understanding prior to the world itself. And that world, unlike man's changing views of it, isn't subjected to the whims of current scientific theory. Perhaps this is why Einstein resisted the vast majority of his colleagues who accepted the idea that what quantum mechanics presented was the limits of what could ever be known. Einstein's underlying metaphysic was that science was an attempt to bypass man's limited understanding over time, and hence to make an interregnum theory final was to ignore both history and reality. As Einstein so famously stated, quantum theory is certainly imposing, but an inner voice tells me that it is not yet the real thing. Quantum theory says a lot, but does not really bring us any closer to the secret of the old one. I, at any rate, am convinced that he, God, does not throw dice.